Right, great. Okay, so we have two persons with their hands up, Muhammad and Aniefjok. I'll just take both questions from your both suggestions. Please go ahead.
Okay, I think the hands they raised was probably a mistake.
Oh, okay.
Just wording. Yeah.
All right, that's fine. So yep, let's proceed. Give me a moment. I'll just have my screen put up. Okay, so currently, right, I believe everyone is upskilling in data analytics, right? And you probably have gone through a number of programs. Today we're going to be focused on SQL or SQL, depends on whichever you want to call it, right? But I'm sure before we do that, we all understand what data analytics entails. Also understanding that some of the things that we're doing in this program would majorly help us when we get on the job, right? Now, the only time that it's going to help you on the job is when
When
you. Uh, yes, I can hear myself from other people's device. So the only time it's going to help you on the job is when you practice. I say one thing a lot in the technical field, right? It's not like other departments or industries where you get to rely solely on your theoretical knowledge, right? In the technical field or in tech in particular, right? The things that you get to do are the only things that you can show out. No one wants to know how well you think or what are the things that you have in your head if you do not have them implemented, right? An idea not executed is as good as being a waste as well, right? So except you have those things implemented, no one wants to know whatever you're saying. They just want to be able to see the things that you've done, right? So you that being said, this means that everyone should be able to implement or practice whatever they are learning or have learned. I'll have my screen shared and then we can just take it from the scratch, look at some of the things in SQL from the very, very basics, and then proceed. Also, I'd appreciate if in the chat we have some persons who would give us where they currently are in their learning, and then let's see where we can focus on majorly. Yep, my screen is yet to come up. I'm yet to put on my screen. So, yep. Okay, this is giving, let me just put this P. So just have this. All right. I believe my screen should be up for everyone to see. I believe my screen should be up now. Yep.
Yes, your screen is up and we can see it.
Okay. So let's start off. What exactly is SQL? I'm sure we are all familiar with what SQL is. It's so some of the things that we're going to be looking at, right? Introduction to SQL. What is the database? We'll just briefly run through them, and then we can take some of the questions or places where you're having difficulties and see how we can break them down or better solidify whatever idea you have of them already. All right, so let's proceed. My name is Samuel. I've already been introduced, and I am just a data person. As already mentioned, I have experience working in a number of data roles, ranging from data scientist to data analyst, which I am mostly focusing on at the moment. And then I also have a bit of knowledge in data engineering, right? And I currently work with core technology on the DB side as a data developer, right? So yep, that's about that. So let's proceed. All right. Now the first things first, SQL, right? Some persons call it SQL, as we have here, SEQEL, which is the pronunciation. And other persons just decide to say, oh, it's SQL. Depends on whichever you want to say. However, they are both correct, right? Anyone you want to mention is absolutely correct. For me, it has always been SQL, right? It's a database tool or a platform that allows you to be able to communicate with your database, right? Now, if we say it's a platform, right, we mean that it is a programming language. Let's put it this way: a programming language that focuses on queries. It gets to query the database and gives you whatever command, the results of whatever command you have imputed, right? So it's a query language that lets you, as a data analyst or as a data scientist or a data engineer or anyone, right? A database is not limited to only data practitioners. So anyone can be able to go to the database, query whatever is there, and get the result, as long as whatever they have imputed is absolutely right. Now, SQL commands and statements help us query information from our databases, which means as a language, it has certain things that need to be implemented, certain rules, certain syntaxes that need to be followed. Right. SQL statements are made up of SQL commands and specific instructions. For example, we have the select. It tells you if you're going to use the select, this is when to use the select when you need to retrieve information, right? You know that, oh, we cannot use the select in our where clause or use it somewhere else, maybe in your join, except you're trying to bring in maybe a subquery or so. So it gives you these commands and tells you these are when you need to make use of them, right? So that's the syntax, and understanding that will help you be able to write your queries effectively. Now, the structured query language is a programming language that allows you as a data analyst to be able to communicate with a database, store data, manipulate the data, and retrieve data from databases. It's a special purpose programming language designed for managing data held in a relational database management system. We're going to talk about some of these briefly. So let's see. At the moment, we understand that SQL is a query language that helps us be able to interact, communicate, store data, extract data, manipulate data that we have in a database. So let's understand what a database management system is. Before we talk about a database management system, let's first understand what a database is. All right. Some of us may already have started working with databases, but let's put it this way. Think about your database as a bank, but where you store your data, right? So similar thing that happens in the bank, we can also liken them to things that happen in a database. For example, if you need to put in money in the bank, you don't just walk into a bank and throw your money up in the air and then tell them, I want my money credited into my account. No one is going to take you serious. People will even pick up your money and say, well, this is a very beautiful day for me, right? But then when you follow certain protocols that have been set, by walking into the bank, you pick up the deposit slip, fill it in with all the correct details, hand it to the person over the counter, they process it, everything looks good, and then they get your money credited. Now, similar thing happens for the database. You need to have your data stored in the database. What do? You get your SQL or your SQL, you write all the queries that you need to write, follow all the procedures or protocols that are needed, and then SQL looks at it or the machine looks at it, right? Everything looks good, everything is all fine. And what happens? Your data gets stored in the database. Now, in the case where you're trying to input your money in the bank, and the information you have provided is not correct, what happens? They inform you that this money cannot be credited to this account because the information provided is not correct. So similar thing also happens in the database. You try to put in data into the database, and then if the data you're putting in is not correct or is not following some of the procedures or rules that have been set, it bounces it back, shows you an error, and tells you we cannot insert these. Maybe because there is there's a break somewhere, or maybe it's trying to go against a particular rule that has been set, which in most cases we'll be talking about constraints, right? So it does not have your data inserted for you or saved in your database. Now, also, when you need to get your money out from the bank, you don't walk into the bank and then grab maybe the teller or the bank teller or the cashier by the neck and then say, I want all of my money right now, right? You probably get jailed for that. But when you follow the right protocols also, where you have to pick up a withdrawal slip, fill in all the correct details of the money in your account. You hand it to the person over the counter, they process it, everything looks good. Also, you get your money. Now, if you try to withdraw money that is above what you have in your account, it tells you that this is above what you have in your account and you cannot have that gotten out, right? Similar thing also happens for the database. You cannot withdraw or retrieve data that is not in your database, right? It will throw you an error and tell you, oh, I cannot find this particular data. In some cases, it might not even throw you an error. It just returns you an empty table, right? So when we liken a database to a bank, we better understand what it is. Now, what is a DBMS or a database management system? So your database management system are those applications or tools that allow you to be able to have databases on your device or in an organization, right? These are like softwares that are used to store data, retrieve data, and run queries. Basically, they have database capabilities, right? And if anything has a database capability rather, it means that they have that SQL capability as well, right? Because it's the SQL that would enable you to interact with your databases. Now, when we talk about database management systems, we'll be talking about platforms like your PostgreSQL, your Microsoft SQL Server, your MySQL, and many others. There's Oracle, there's DB Browser, there's MongoDB, there's Cassandra, there's so many of them, right? They allow you to be able to interact with databases, have your databases created as many as you want, or if they have set limits and the likes. Right, so I believe that's about that for DBMS. Now, a number of us would probably ask, why do we want to work with SQL, or why should you even as a data analyst work with SQL or learn SQL? First off, it's the most important or in-demand skill for you as a data analyst, right? Maybe for a data scientist, you might have something else that is more required, or data engineer, something else that's more required. But in the case of you as a data analyst, right, the most in-demand skill will be SQL. Now, this is because the majority of data that you're going to be working with, right, will be gotten from a database, especially if you work in an organization. The majority of data you'll be working with would be from a database. In other cases, you get data from your other data sources, maybe from a cloud environment, which in most cases should still have a database stored in the cloud as well, right? In some other cases, you'll be getting your data from maybe surveys, carrying out surveys. In some cases, your surveys will still be stored in a database, right? In other cases, you'll be getting it from a web environment. Maybe you want to analyze a Jumia data also, you can get it from their website or maybe from Wikipedia, right? But then the majority of data that you're going to work with as a data analyst will be coming from your database. So this is like the number one skill or tool that you want to give your focus on. I usually say it also that when you go for um, data analyst interviews, a lot of times, right, your questions would revolve around SQL, right? And then other questions would come as maybe they want to understand what is your idea of solving business questions and the likes, which may not involve SQL, right? But a majority of times, your questions will revolve around SQL, except maybe the organization specifically says, you know what, we're not working with SQL, we're going to focus on Excel and maybe any other visual analytics tool, maybe Power BI or Tableau or Flourish or any other tool. Right. So SQL is widely used language for working with data. All organizations have data and they typically store them, the most part of them, in a database. So this means that a lot of times there would be that tendency for you to go to the database, extract data, and work with them. Now, SQL also is a very, very versatile tool or language that we can use for a variety of operations, right? It's not just tailored to creating database and then storing data inside the database. There are lots and lots of things that you can do using SQL. In my organization rather, We use SQL to send out mails, or not like your what you do with your Gmail or Outlook, right? But of course, we have it set up in a way whereby we can be able to let the database or configure it so that it sends out an alert or email when certain things go wrong or so. So maybe you might be sleeping and then the database sends you an email as maybe database administrator or a data developer or data engineer handling that particular aspect, right? Your SQL can also be used for lots of computations. There are many things that it can do for you. It's a very key language when it comes to building and development of products. Any of the products that you see today, SQL plays a very, very strong role in their development, right? So it's not just for you as a data analyst. There are so many things that can be done. A lot of times, as long as I'm on my device, right, the only thing I use for performing calculations is my SQL. I don't go to the calculator on my phone. I don't go to pick up any other calculator. I don't even go on my device to launch my calculator app. As long as I'm on my device, right, if I need to perform any calculation, I just open up my DBMS and get to put the calculation in there. So it gives me the exact result as I should have on my device, right? So it allows you to be able to perform a wide variety of operation, data manipulation, aggregate your data, have them properly summarized, data visualization. So this is a bit tricky, right? Because by default, SQL does not have like that data visualization capability. However, with some add-ons or plugins, you should be able to visualize the data in your DBMS. In most cases, I think we have that for MySQL. MySQL has that capability where you plug in a data visualizer, and then it lets you visualize your data right there in MySQL as well, right? So this basically makes it a valuable skill for people in a variety of roles, including data analysts, data scientists, software developers, and business analysts, and of course, every one of us on this call today. So there's plenty of things that we can do with SQL, right? Other than what we already know. So many things that we can do with SQL. Another reason to learn it is because it's one of the most simplified languages to learn. If you may have difficulty learning Python programming, right? Of course, everyone says Python is pretty much easy, especially when you compare it with other programming languages. But then you find out that, oh, SQL is even more easier to learn than Python programming, right? Once you understand SQL, you then start expanding your knowledge or your knowledge capability when you tend to go for Python or R or any other programming language. Now, the trick about it is that if you learn other programming languages before coming to SQL, you will be able to easily understand it, right? But also, SQL gives you that edge of understanding what a programming language looks like, some of the rules and syntaxes, and then you can now start trying it out on other programming tools when you go to work with them. Maybe you want to work with Python, you can use some of the skills or knowledge that you've gotten from SQL. Oh, I need to ensure that my variable names are like this. I need to ensure that when I'm naming whatever variable or any other thing that I need to, they do not need to have spaces inside of them. Instead of spaces, I'll have them replaced with underscores or have them chunked together, right? So some of these things are things that would apply across all programming languages. Also, SQL is a declarative language, which means that you don't have to show it every single step all the way. You just tell it what to do. Oh, I want you to retrieve me this data from table A, where 1 is equal to 2, right? And then it looks at table A, gets the data where 1 is equal to 2. You don't have to tell it, oh, go to table A and then check inside table A. First, bring out this, remove this one, then do this. And no, you don't have to show it every step, right? You just tell it what to do, and then it goes there, performs that operation, and returns you the result, right? Unlike other programming languages where you have to maybe define a function and then tell it, oh, I need you to do this. Check for this particular one first. If this does not happen, then go on to the next one. Check for this. If this happens, then return me this. If it happens, but it does not happen well, then also do this, right? So SQL is pretty much easy to learn compared to other programming languages that you may want to try out later on. Okay, it's also a very high transferable skill. When once you have a knowledge of SQL, especially in, let's look at it in two ways, right? One would be in working with one SQL to, I believe for this program, we have a particular DBMS that we worked with. Maybe it could be SQL Server or MySQL or Postgres. Now, the thing about SQL is that once you have a knowledge working with one of them, that knowledge can also be applied for other DBMS tool that you get to work with. So if you work with Postgres currently, it means that you should be able to apply that same knowledge in MySQL or in SQL Server. However, a bit of things might seem different. Sometimes the syntaxes are like different, right? I believe we understand some of these things. Maybe in a place where you're supposed to use serial in Postgres, you might use something different in MySQL, maybe auto increment in MySQL, or identity one by one in SQL Server, right? So some of these things might just seem different, but for the most cases, all the syntaxes are almost like the same. Maybe in MySQL, for places where you'd use date time in SQL Server, right? You'd use timestamp in MySQL or Postgres. So things like that might just be different. But other than that, every other thing stays the same. Same syntaxes, same knowledge, same process of running things. You just have to apply it to the other one, understand how it works in the other environment, and then you can also implement better. Right. Now, also, it's a very highly transferable skill and can be applied to a variety of jobs and industries. This means that even if you decide to not become a data analyst, you might work in an organization as maybe a product manager or product person, and you still have to work with SQL because you need to be able to go to the database, collect some information, utilize it for whatever process you're trying to do. Sometime last year, I trained an organization on SQL, right? And it wasn't because it was a data team, it was a product team, a product support team that would resolve issues for customers. Now, why did they need to learn that? Because they need to be able to go to the database, retrieve information of customer complaints or inquiries, and then use all of that, have it properly checked or analyzed, and then they can now provide feedback to the customer, right? Maybe they need to find out how long this customer has been complaining about it, or how has this issue persisted for, and the likes, right? They can get all those information from the database. If those are like things they cannot be able to get from the application side. Example, in my organization, a lot of times when things happen on the application side, they might not be able to get it directly from the application, and then you have to look into the database to be able to retrieve the data from that, right? So I work with an organization that provides fintech services or that helps digitalize banking operations. And apparently, I kind of work with over 1,000 databases on a daily. Databases that are absolutely not like my organization own. For some of the banks that you may bank with, right, your databases are being managed by myself and a team of other persons, right? So, yep. Some of these things can be implemented. So most of the times when something happens, or maybe you make a transaction and there's a hold up on it, or the transaction declines, it might not show up on the application side. But when you have a look at the database side, you should be able to see, oh, this transaction failed. Why did this transaction fail? This was the error that this transaction failed. Although we're unable to see it on the front end, but on the DB, all of these things get captured. Right. So we've been able to talk about what a database is as a bank that stores data, right? Or an organized collection of structured information or data, typically stored in an electronic system blah blah blah. So let's look at the next one. So we have DBMS. We talked about that earlier on. DBMS can be categorized into two, relational and non-relational. Whenever you get to maybe basic interview stages, they might ask you what do you understand by relational databases or non-relational databases. Which one have you worked with? Which one have you not worked with? Right, things like that. Now, for the most cases, as a data analyst, you would work with a relational database. A relational database, as we call it, or as the name implies, right, is one that lets you be able to have relationships between your entities or your tables, right? So sometimes maybe in your interview, they might not call it tables, they call it your entities, and then you just need to understand, oh, yeah, I've not heard this one before. What? Sorry, please come again. What do you mean by entity? Right. So you want to understand, oh, that's a table in the database, right? So your relational database lets you be able to work with tables, connect or create relationships between one of them or the other. Now, this is the same thing that you get to do in other tools like Excel, Power BI, and the other ones, where you get to model your data so that you can be able to see the relationship between them, right? So in a database, in a relational database, it lets you be able to have all of those things. And most likely, through what we call normalization, right? Where you have to break your database into sub tables, right? So instead of one table having all the jargons together, you want it to be more effective, and then you break them all into sub tables. Each table having only the information that relates to that particular table, while also having some bit of information of another table or something that can create that relationship between them. Let's see. So we have NoSQL databases, also known as non-relational databases. For example, when we talk about relational databases, we'll be talking about databases like your PostgreSQL, MySQL, SQL Server, Oracle, what else again? I think DB Browser as well, right? Those are like relational database management systems that allow you to be able to have relationships between your tables. But when it comes to non-relational database systems or NoSQL DBMS, they basically do not enforce that relationship between your tables. You can have your data stored in columns, you can have it stored in graphs, you can have it stored as a document or as a key with a value attributed to it. Let's see what's this. Okay, so basically, in most of your applications that you get to work with, most of your mobile applications or software that you work with, these are the kind of databases that are created for them. A key value kind of database where it takes in a key and stores the value of that. In most cases, the values are usually stored like all together and assigned to a particular key. Right, so you have one key that would be having maybe like millions of values, right? So it's different from how you get it stored in a database. You have documents, you have your files or your data stored as a document or so, right? So these are basically unstructured data when we talk about structured and unstructured data. So I believe that also helps. We can easily say the relational database management system stores structured data in the sense that it helps you put them all in tables and creates relationship between the tables, right? While your NoSQL or non-relational stores unstructured data in non-tabular format, right? You can put them in column family, no relationship between one and one another. You can put them in graph, and then they just have to connect to each other, but not like you would have for a table. For example, we have MongoDB. There's also Cassandra DB. There's Amazon Redshift and other ones that we have as well that are non-relational databases, right? So they basically do not store your data um, in tabular formats or in structured formats. So what are like the cons and pros of your relational and non-relational? For relational, they are pretty much easy to use and set up. They are universal, compatible with many tools. and great at high performance workloads. They also take in structured data, which is a very, very good thing because as data analysts, you will be working with mostly structured data unless otherwise requested by your organization or maybe following the type of analysis you want to carry out. For example, if you need to carry out maybe a sentiment or text analysis, it definitely means that you most likely will not be working with a structured data, right? So you need to figure out how you can be able to work with that, right? Also, the pros for document data model or non-relational data base. No investments to design model. You don't have to stress yourself trying to create huge tables and all of those. There's a lot of rapid development cycles. In general, it's faster than SQL. I think if you work with MongoDB, you pretty much understand some of these things. MongoDB is a non-relational database management system, and you'd see how fast your results get when you execute something compared to running them in SQL, right? But then again, there's always that advantage of working with a structured data over an unstructured data, right? So these guys run well in the cloud. And then what are like the cons? SQL is time consuming to understand compared to a non-relational. I believe for me, you may actually find more difficult learning a non-relational database compared to a structured. So if you need to, I always advise that you start off with your structured data or relational databases before you can then proceed into non-relational, right? Can be difficult to scale compared to non-relational. So when we talk about scaling, we are talking about expanding its capabilities, maybe in terms of storage, in terms of properties that the database would have in order for it to accommodate more and more data compared to a non-relational database, right? Okay, so a database typically consists of tables or things that we call database objects, right? I believe we're all good. Can everyone please confirm they can hear me still following?
Yes, I
Yeah, we
can
can
hear
hear
you.
you.
Yes, we can hear you.
All right, I can see two hands are up, so
Yes, we can
let's
hear
take
you.
them. Segiri Debbie. Hello, Debbie.
Okay, Olashigiri Debbie, your hand is raised. Do you have any question? Our mentor is ready to take your question. All right, Olashigiri Debbie.
If there are any questions, I think we can put them in the chat. I'll probably look at them
Yeah.
at intervals. So let's see. So I'm going through the chat to see what we have there.
Okay, we do have questions yet. Just people dropping their ID, which is not necessary. So everyone, you can actually stop dropping your ID. A Google form will be sent at the end of the class to collect that. So yeah, we can just concentrate and then we can drop off questions that we have or that we want to ask. I believe that works. All right, so Samuel, I think you can continue.
All right, thanks. Okay, so a database is typically made up of what we call database objects. Your objects involves a number of things, like your tables. Your tables also has its own table objects, right? So when we talk about database objects, we'll be talking about your tables, your views, your procedures, indexes, and other things that also make up your database. Now, a lot of us would have noticed that when you create your database, you don't have to say too many things. The only thing you just have to do is to write the create database statement and specify the name of the database you want to create. Once you have that executed, what happens? Your database gets created, and there's a lot of other things that you can see, right? How is that happening? Now, this is because your create database statement has a lot of rules inside of it that tells the machine or the DBMS what to do. It tells it, oh, this person is trying to create a database called this name. So what you're going to do is to create all the components of the database that would help this particular person be able to store data effectively or manipulate the data that will be stored there. Now, a database, like I mentioned, is typically consisting of your tables, which is like the number one thing anyone would work with when they visit a database. The table has columns and rows, and then your columns are defined by your name, type, the size, and the constraints. Very, very important. There are a couple of interviews that you attend, and then they ask you, how do you define your table, right? And then some of us will just say, the table is the name now. That's just it. Right. So it's important to understand that your table is defined by the columns that are inside of it, and then your columns are defined by the name of the column, the type of the column that's the data type, right? What type of data is it going to be storing? What will be the size in a case where size is important? For example, where you're storing text data or even numerical data. I believe we understand that numerical data also has sizes too, right? So that's also very, very important. And then constraints as well. So when we look at these four aspects, we can be able to understand how our columns or our table is being created. Each column has a name. Each column has a data type, a specific data type that it can store. Of course, you cannot store a text data inside of a column that has an already defined data type of integer, right? So things like that are very, very important. You also cannot store numbers in a table or a column that has integer as its data type. You cannot store more than 9 numbers at a time. For example, if you try to put in your phone number for a column that contains just integer as the data type, it's going to truncate the data for you because it tells you, oh, 9 is the limit and you can't go beyond that. So if you need for like larger numbers, then you probably want to go for a data type like big integer and the likes, right? And then constraints are like very, very important. Constraints are like those guys that just keep you on the safe side, right? They don't want you to cry and then they are just there to help you. Tables are related through PKs and FKs, which are your primary keys and foreign keys. Remember earlier on, we talked about relationships in your tables, right? One table being able to connect with another table. You do that because of the primary keys and foreign key relationships that we have there. Now when it comes to data types, what exactly are data types, right? Data types are how your columns are defined, right? This is basically what decides what type of data will be stored in a particular column, right? So it defines or tells you the property of the data that can be stored in that particular column. Now we can categorize this into three numeric data types, character data types, and date or time data types. Of course, some of us would say, oh, what about Booleans or the other ones, right? They are there as well, right? But these are like the major ones that you most likely would work with. There's the numeric data types that involves numbers. It could be floating numbers, it could be whole numbers. When we talk about whole numbers, right, we'll be talking about integer, small integer, big integer. When we talk about floating numbers, we'll be talking about floats, decimals, money. Money is a data type for storing financial data. For example, you want to put in financial data or say, oh, this is the price of a particular product. You can decide to use money as the data type, and it will store it the typical way that money should be stored. If you store it as an integer, it does not give you the 0.00 that you typically have when you receive your money from person, right? But then when you store it as a money data type, it gives you the 0.00. So when we talk about floating numbers, we're talking about all those values that have decimal places afterwards, right? So numeric data type consists of your integers. It could be your small integer or just integer or your big integer. It could be your floating numbers or your decimals or your money, right? So those are that. And then we have character data types that includes text characters. Anything that has to do with text characters, your character data type would suffice for that, right? We have the character that just takes in your text characters. We have the variable character that takes in a variety of text characters. And then we have the text that takes in longer text compared to any of these other guys. I think the limit for your variable characters would be about 65,000, but your text can take up to millions of text characters compared to these other guys, right? So it's important to note some of the sizes of these data types. What are like the maximum of it? In most cases, maybe when you're trying to accommodate for as much data that you need to, and you do not want to make use of the text, maybe instead of putting variable character 65,000 or variable character 20,000 and the likes, you can just use your variable character and max it. So you have max inside of the parentheses, right? Instead of just putting a particular figure. But I think that only works for some select DBMS. I'm very certain for SQL Server because I use that a lot. I know for MySQL, it doesn't work. You basically have to use maybe long text or medium text, right? When you use variable character, it has a limit, and then long text works better for that. And then for Postgres, I'm not so sure about that, but I know variable character absolutely works fine, but I just haven't tried out the max in Postgres. And then of course we have the text, which basically takes in as much text characters as possible. And then lastly, we have the dates and the time data types, right? For this, they basically carry date information. It could be just the date, it could be just the time, it could be the date and the time together. It could be a timestamp as well, right? So they basically as either of these date related values, right? And then we have other data types as well, like the XML or JSON, which are the in most cases unstructured, right? So XML and JSON are like unstructured data types, right? In some cases, you'll be able to find them defined in your structured data as well. But still yet, if you have them in your relational DBMS, it means that they still have to be inserted into a table, right? Compared to when you have them in your non-relational DBs. So we have the XML, which is extensive markup language, stores your data basically in keys and attributes, similar for the JSON as well, which is a JavaScript object file, right? And then there are other data types as well, like your binaries, your image data type, and there's also your geographic data type, right? Trying to see what it stores data in. I can't remember right now, but there are lots of data types that we can be able to work with. But majorly, you work with numeric data types, character data types, and dates or time data types. I think for your image, right, they are being stored as blobs, image blobs, and you just need to understand them before you can work with them. In most cases, when you have an image blob, it takes a lot before you are able to have it properly viewed from the database side. Now let's talk about integrity constraints. What are
All right,
integrity
Sam, I'm so
constraints?
sorry to cut you. I don't know. I was thinking you might want to take this question before moving on to the next one. So somebody is asking, please, I have been coming across INT4 in my learning, also INT8. So the person is asking, what are the difference between this data type and integer? Okay.
Okay, so I'm not sure about INT4 and INT8, but I think that is dependent on the DBMS that you're working with, right? So I can't be able to give it like a proper answer for that on
Okay, so I
INT4
think it's
and INT8, but I
everyone,
think that's something we can be able
you're
to
making use
do.
of the post gray
What are the difference
SQL.
between this data type integer? I can't be able to say because I basically don't I don't think I have encountered that, but if I'm correct, it could probably mean the byte of those integers, right? That it can actually take. Maybe 4 should be for like 4 bytes, and 8 should be for like 8 bytes of data, right? I think if I'm correct, I probably have to look it up. But other than that, I don't think I've had a time where I needed to specify, oh, it has to be integer 4 or integer 8, right? But I'll probably look it up and see about that. Okay. Mohammed says geospatial. Yeah, for geographical data, absolutely. Nope, not location. So location can be your column name, but that's not the data type for it. Pixels, absolutely no. Okay, so integer 4 is equal to 4. I think that should be bytes, and integer 8 should be for bytes as well. Right. So if I'm correct, I think that's that. Um, so we'll probably look it up maybe later on and ensure that we get like a confirmation. I don't think there are times where I've had to like define that, oh, I want an integer 4 or an integer 8. Right. I'm only defining an integer or a small integer or big integer. Right. Okay, I believe we can proceed. All right. So let's talk about integrity constraints. What are integrity constraints? Now, I like to define integrity constraints as those guys that are there to like save you from problems, right? They know that you're going to make problems, right? But they want to be there to help you out. Now, the only time they can help you out is when you call on them. If you don't call on them, you just get all the problems that there is to get. Now, integrity constraints are those set of rules, right, that you implement on your database, on your tables, specifically to enforce data integrity. Now, they help you make sure that at the end of the day, your data stays true and accurate at all times. No duplicated data. You're not trying to break one data from the other one. And like when it comes to integrity constraints, we have the not null, which basically when it is being enforced in a particular column, it means that this column must require or contain data. Now let's think about it this way. A number of times you probably would have gotten into a survey or gotten some Google form to fill. Now you notice that on some fields where you have to put in your information or data, it always has like a red asterisk which says, oh, this field is mandatory. Now, on the database side, what it translates to is the table is created, and for this particular field, there's a not null constraint that is set to ensure that this place must collect data. There's nothing you can do. You cannot complete the form without imputing data into those fields. So when you have a look at that, comparing it to your forms, you'd be able to better understand, oh, this is why there's always the asterisk, the red asterisk in my forms, right? It tells me this is mandatory. You can't complete the form without imputing your data in here. So, but on the DB side, like I mentioned, it's the table creation process would be stored as a not null constraint, which means it must not collect blank data, right? It must have a valid data inserted into it. It might be gibberish, it might be any nonsense that you put in, but then it must not just be empty. Right. Now we have the unique constraint, which allows us to be able to ensure that the data in a column is absolutely different from any other data that will be coming into that particular column. Now, in many cases, people tend to confuse the unique with the primary key. They are two absolutely different things, right? For the unique, it ensures that your data that gets imputed into your columns is different from any other data that will be imputed into a particular column. For example, we can have a look at the number of persons on this call or everyone on this call, and then we can say we want to set a unique constraint that only accepts each person's name once. So if it sees one name twice, for For example, I can see that when you go through the people on the call, you can see that there's two of me, right? One is presenting the screen, and then there's just me talking. Now, when we set a unique constraint, it enforces that, oh, regardless of what we want to do, I cannot accommodate two Samuel Iheagwam at the same time. You can have a Samuel with another name, but it cannot be the exact same name that we have. So it basically just enforces that no two names can be the same in that particular column. Now we need to be careful when to make use of it. For example, if we're taking details of everyone on this call and then we want to break it into two columns, first name and last name, we cannot set unique constraints on the table, because at the end of the day, it means that if we have one person on the call who puts in their first name as Adibola and then their last name as Oluwaseyi, and then in maybe another person joins the call and then their first name is also Adibola, but their last name is maybe Miriam, it doesn't go through. Your query or whatever you're trying to insert into your database will get bounced back. So you want to ensure that you know when to properly utilize the unique constraints. Maybe in cases where you're trying to get like a list of African countries, and then you can set a unique constraint to ensure that you're not having any repetition of data there, right? So your unique are specific for your columns. And then we have the primary key, which is like the most important constraints that we have, right? So your primary keys help you to ensure that every row stays unique from the other row. Now, like I mentioned, the primary key is different from the unique. They tend to perform similar operations, but in different ways. The primary key ensures that every row is unique. The unique key or constraint rather ensures that the data inside every column is unique and different from each other. But your primary key is focused on the row level and ensures that, oh, I've seen this row before. We cannot have the same data repeated again, right? So that's basically what your primary key does for you. It helps you ensure that your data stays true at all times, no repetition of extra data, and it just assigns like a unique key to it. Now, some of us may want to ask, how strong is the primary key also? Now think about the primary key like your NIN. If you're in Nigeria, think about the primary key like your NIN. No two persons can have the same NIN, right? So the NIN is a good example for the primary key. So it means that in anywhere in the government database where your NIN pops up, it means that this is the person whose NIN we can see, right? Similar to when for some of us that were in university or that are currently in universities, right, you notice that there's a particular key that separates you from every other student, right, which in our case would be the matric ID. So you notice that, oh, back then in school, your lecturers, maybe you fought or you do something and then they want to have you punished. They are not going to request for your name or ask you, what's your name, what course are you studying? The first thing they're going to ask you is, what's your matric number? Or just put down your matric number. That is because that is your primary key that uniquely identifies you from every other student in that particular school. No two students can have the same matric ID. I don't think that that's ever possible. If it's where, then it probably needs to be resolved, right? But no two students can have the same matric ID, even if they were twins from the same mother, the same father, the same home, attending the same school, the same course of study, it still would not have that. All unique constraints can be primary keys constraints, but not vice versa. Hmm. Primary keys cannot be unique keys, but unique keys can be. I don't think this actually works. So, like I mentioned, right, your unique constraints are focused on columns. So it means that for multiple columns, you can set your unique constraints. I give an example using the names, right? If you set that, oh, you want the names of everyone on this call to be unique, it's different from setting a primary key. We use PostgreSQL, okay? I think it's using keyword for another DBM. Okay, okay. So okay, so I think I get this now. I think I get this now. Okay, so that's understandable. But yeah, primary keys basically ensure that one row is different from another row, while your unique constraint basically ensures that one data that is being inserted into your column is different from the next data that will be inserted into that column, right? It ensures that there's no repetition of that data again. One thing that we can agree that they both do is that they enforce duplicate actions. They ensure that duplicates are not entered into your table. I think that's one thing that they both perform together, right? And then, of course, we have our foreign keys. So foreign keys are those guys that are just there. They're just there to support the primary key. So they play a referential role. They just reference the primary key in another table. They just basically say, oh, you know what? I can see that you're there. You have the same information as I have. So I'm going to feed you with some of this information as well, right? Foreign keys are like primary keys that sits in another table that is not their own table. And I think I may have missed it, but every table must have a primary key in order to enforce a no duplicate or referential integrity, right? Every table must have a primary key. And then your foreign key is like a primary key that you find in another table that is not its original table. For example, you have your sales ID in a customer table, right? That is not the sales. So it means that the sales ID in the customer table is a foreign key that will be referencing the sales ID in the sales table. Let me see what we have in the chat. Okay, difference between data unique and primary. I believe we talked about that already. So unique are focused on columns, while your primary keys are focused on row levels. Then we have the check constraint, right? What the check constraint does for us is that it checks that a particular value that has been entered meets the requirement that has been set in order for the data to be stored. For example, you're collecting a survey, right? And then you set a check constraint that this survey should only be for persons that are above the age of 18 or from 18 and above. Now, it means that when you collect age data, right, the age column has already been set a check constraint that says, oh, this age, whatever age that's entered has to be greater than or equal to 18. So if anyone fills in the survey and then their age is below 18, what happens? It throws them an error or bounces them back that they cannot do this, right? So basically, that's what the check constraint does for us. Or maybe for some of us, right, that may have other things to do. Maybe you're trying to complete a business process or a grant. Your is it like one done in Excel? Yep, absolutely. So maybe you have like a grant that you're trying to apply for, and then they tell you your business must meet certain requirements or should at least have a certain amount in revenue, right? So, and then you decide to have coconut head like me and you go on ahead to apply. Now, if they mention that your business should at least have a revenue of around like 1K, 1K dollars for the last 3 months, and then you have a strong head like me, you've only made around like $200, and then you're going to apply because, of course, you're very hopeful. Now, what happens is when you fill in all the details, it's going to decline your application, right? Because you are not meeting the requirements that has been set. When it checks and sees that your revenue is not up to what has been set, it declines your request. So basically, the check ensures that a condition that has been set meets that particular requirement before it takes in your data. I believe we're good with that. Everyone, are we good? And then, of course, we also have the default. So what the default does is it stands as a substitute for when data is not entered. For example, maybe you're trying to also apply for a grant, and then it's not a mandatory column for you to not input your data. But then it's being set that in a case where this person does not impute any data here, we're going to have a default value for that person, and the default value in that case would be 0. So this means that instead of the table containing blanks, it's going to have a default value of 0, right? So that's a good one also to avoid having nulls in your data. So these are the integrity constraints that we have, and they are there to ensure that your database, whatever data is being entered, stays true and accurate at all times, right? Now, it's also important that we understand the ACID properties of a database. I believe we'll talk about that shortly. So let's proceed. All right. So we have categories of SQL statements. They are the data definition language, the data manipulation language, data control language, and the transaction control language. And we can also call these the sub-languages of SQL or the categories of SQL statements. Right. Let's start off with the data definition language. For the data definition language, it consists of SQL commands that can be used to define the database schema. What is the database schema? I believe that's something that we even missed out on. Now, at some point during my job applications, I got into an interview where, I think it was like the second to last phase of the interview. It was basically with the CEO of the organization, right? I eventually had that interview twice. One was over the phone, and then the CEO kept on asking, "What is schema? What is schema?" And then I'm looking at like, why are you asking me what is schema, right? So I eventually had that sorted out, but then I figured that a lot of interviews would also require similar thing. Now, a database schema is the logical structure of your database object. It is how your the objects in your database are being carried out in activities. For example, think about it this way. You how do we put it? Okay, so you go to, let's say you go to your workplace and then you need to get back home. How do you get back home? What is the process of you getting back home if you have to structure it? You need to board a cab or maybe a bus that takes you to your street. From your street, you get into your compound. From your compound, you get into your building. From your building, you get into your living room. From your living room, you get into any other room that is needed there. Right now, if we have this outlined, we can see the pathway in which you have gone from your workplace to your home, right? Now, your schema is simply the same thing. It is that logical structure of the objects in your database. It is the arrangement of those objects in your database. Now, let's take a typical one. You want to get, let's say you're working with let's assume a World Cup data, and then you have a couple of tables in there. Now you need to query a particular table, and of course, maybe you just want to query the column, just one column there. Let's say the World Cup winners. So let's say you're doing select all from select World Cup winners from your winner table, right? Um, Now, if you need to select from that winner table, right, how do you get into the winner table? It means that you need to first get into the World Cup database or schema, right? For Postgres, I think it's been called schema, but it's the same as a database. Now, you need to first get that and then get into your table, and then you can now get into the columns that you want to query. Now, I'll say it again. Your schema is the logical arrangement of your database objects, right? So when we look at it, I'm not sure if I'm going to my DBMS right now, but let's give that a moment. We'll look at that. So your schema is basically the logical arrangement of your database objects, right? It tells you how the objects in your database play a role in your work at the end of the day. Your columns is found inside your tables. The table is found inside your schema. For SQL Server, we can have schema as your DBO or an actual defined name, right? And then your schema is found inside of your database. We'll look at that using the adventure works shortly and then see to understand that proper. But then when it comes to data definition, it basically, the commands that we have here basically help us to define the structure of the database by creating the database, dropping the database, altering the database, truncating the tables in the database, commenting or renaming the database. And when we talk about defining the database structure, right, we'll be defining things like the database itself, the tables in the database, we'll define procedures, we'll define views, we'll define indexes, and many other database objects that can be defined, right? Now, all of these that I've mentioned, they require you to say create database, create table, create procedure, create view, create this, create index, and any other, right? Now, as long as they all have that create, they also have the drop and can also function with the alter. Right. Except for I think for procedures, right, you either create or alter your procedure. And for some DBMS, you create or modify your procedure, right? So it depends on the DBMS that you're working with. And then the truncate is specifically tailored for your tables. The truncate and the comment, they are specifically focused on your table as well. Now we have the rename, which works for all of these guys. Rename procedure, or rename your index, or so once again, right, it depends on the DBMS that you're working with. Sometimes you might be finding that, oh, what you need to do is to create or alter your procedure and then change the name of the procedure. For some others, it could be to rename the database. It could be to use a stored procedure to rename the database, like we do in SQL Server and other ones as well. So it's dependent on this DBMS that you'd be working with, right? But then these commands here, they basically play one role, which is to define the structure of the database. Define the database, you define the tables that need to be stored in the database, and then you also define the columns that need to be stored in the tables, right? So next we have the data manipulation language. These guys basically deal with manipulation of data that is present in the database. Now, of all things, right, these are the guys that you need to be scared of the most, right? I think so. In most organizations, as a data analyst, you would not have access to create or drop or alter databases or database objects. You would not be able to do stuff like that. But then things that you need to be scared of the most in an organization are the insert, the updates, the delete. These guys can jeopardize your entire career, right, as data analyst, especially if there are no restrictions for that. So if I'm laughing about this because some is this some months back? Nope, I think about last month, right? I have someone that works with me who used to be an intern but was given a full-time role. And then sometime last month, you know how when you get on the job and then you're all pumped, there's so much energy, you want to work, you want to do things. And I tell him all the time, in order for you to perform any update operation, right, you need to do this particular thing first so you can be on the safe side. But on some cases, he has one way or the other happened to like skip those parts, right? And because I cannot always be on the database with him to monitor him, do some things, right? An incident happened where he eventually updated an entire table with one particular value. Now, so he omitted the where clause, right, during his updates, and that eventually caused a lot of issue. Now, it's really funny, right? Because when when he reached out to me to help out, I was just there looking like, you will not kill me, oh, you will not kill me, because it's absolutely crazy, right? So that's why I said these are the guys that you need to be scared of, when you get into an organization. By default, you will not have access to be able to carry out these operations. But in a case where you find out that you have that access, you need to be careful of whatever you do. The database is a very, very delicate platform, right? Of course, there'll be backups, but you can't always rely on your backups, especially when you have live data coming in every time. Now imagine you have let's say you have 5,000, or let's put it this way, you have 100,000 naira in your account, and then you just refreshed your account and then you're seeing 2,000 naira simply because someone has updated all the amounts that every customer has with one customer's own amount. Now that's going to just be driving you crazy, right? So some of the things like this, you just want to ensure that you're not playing with things like this, right? So the data manipulation language deals with manipulating the data or the records that you have inside of the database, right? And then you want to be sure that you're not utilizing them in the wrong way. Like I've mentioned, in a typical organization, right, you would not have access as a data analyst to do stuff like this. So, but it's always important to learn how to do them. Ensure that when you're updating or deleting, you're always utilizing the where clause. Very, very important. Now, also ensure that you're having transactions for whatever you're doing. Transactions could be a great one to help you. When you commit your transactions, you can roll back where the time limit affords you that. Now, also, there are limitations with your transactions. When you commit a transaction, it has a time window where you can roll back. So imagine you make an update to a database, or you insert data into a database, a table rather, and then you only notice the next day that you've made some wrong manipulations. When you go back, your transactions are no longer going to be open for you to roll back. So we need to ensure that we're taking proper measures, right, when performing operations like this. I made a LinkedIn post about it. If you need to ever make an insert or update or delete operation, ensure that you're taking a backup or a copy of your table before you do things like that. That way, you know that, oh, I have a backup available for me, and then you can easily roll back using the backup data that you have, right? Or we update it again. So these are the guys that we have here. Now, a lot of times I tend to not include the select in your data manipulation language, even if it plays a good role there. The select should be categorized as a data query language on its own, right? Because the role it plays majorly is to query the data that is in the database. So for some platforms, they categorize it as a DQL, a data query language. Other platforms tend to classify it as a data manipulation language. But in my own way, right, I believe it's a DQL because it queries the data in the database in table. We also have the data control language, which mainly deals with the rights and permissions and other controls of the database system. For example, when you get into an organization as a data analyst, the first thing anyone would do to allow you access the database will be to grant you access, right? To create a user role for you, or maybe create a login for you, assign you to a user role, and then grant you access to specific databases where you need to collect data from. Now, if this is not being done, you cannot access any of those. Now, the databases that you have on your device, they are yours because you don't need all of these permissions because they are on your device or on your environment. So you are the system admin or the database administrator. But in a typical organization, you will need to be granted access to the databases. So you need to understand what database you're going to be working with and how to access those databases. And then, of course, we have our transaction control statements that helps us with transactions in a database. So transactions are a set of operations that are being tagged as one, and they get executed as one body. If it fails, they all roll back as one body, right? So we have commands like the commit, the rollback, save point, which saves to a particular point in time, and then set transaction as well. Now, like I mentioned, these guys are actually absolutely great for helping you when inserting data, and the likes. So I believe that's about that for now. If you are able to attempt some of these, then we should be good. What are like the three examples of data definition commands? What command is useful for retrieving data? What happens when you use the check constraint? There are key properties that define every column in a table, which I talked about. What are these column properties? How many of these column properties is mandatory? Which of these column properties is optional? So these are some of the things that we need to note. Name is mandatory. Data type is also mandatory. Size is optional, depends on what size you're getting there. And then constraint is also optional, right? So it's important that we note some of these things. Let me know if we have any questions. Let's take them before we can. Who here is studying? Hello, Isha.
Hello, sir.
Hi.
Yeah, good afternoon. Thank you so much for this educative session, sir. Please, I just have a question. Like, I don't know if you end up getting to that aspect, like for someone that has like maybe a Postgres, whatever app on the laptop, how can one create a database like a database that one can just use by oneself? Maybe I want to actually I want to actually like create maybe an SQL file in the database. I don't really know so much about this database, so but like something like that. But like a database, I'll have a username by me, and I'll be the admin, and how I can actually add people and limit the access that they have. Can you put us through that, please?
Mm. Okay. We'll see about that. Definitely we'll see about that.
Thank you, sir.
Right. So there's a question in the chat that says, this is from Reginald. Please, can you recommend at least a website doc or article that specifies the convention for defining constraints on data types of various columns, depending on the nature or information to be stored? Take, for instance, a column that stores first names of people and another that simply stores the full name, let's say name. Now, the length of varchar for the two columns will be different, probably varchar 20 and 50 respectively. Same goes for emails, phone numbers. So which website or article specifically lists out the conventions for situations like this? So I think basically, I don't think it's much of a complex thing. I think it's understanding what data type you want to use, unless maybe I don't get the question, right? I think it's understanding what data type you want to use. Once you understand the data type that you want to work with, then you should be able to have it defined in your table. Same goes for the rest guys as well, right? I don't think it's for instance a column that stores first names of people and then another that stores the full name, call it name. The length of varchar for the two will be different. Yep. So I don't think this is much of a big deal. I think it's just basically saying, oh, create a table and call your table this, and then you have a column that stores first name, last name, and then another column that stores the name, and then you can define, oh, the first name column should take 20 characters only, the last name column should take 20 characters only, and then the full name column should take 50 characters. I think that absolutely works with ease. Same goes for emails and the other guys. I'll check and see if there are any resources that can do that. From experience with working with databases, can you recommend two MySQL database hosting sites? One that is expensive and robust for handling big data of top companies. So unfortunately for me, I do not work with MySQL in depth, right? So I may not be able to have this information. For hosting sites, MySQL database hosting sites, I can't be able to give like a proper information for this because I do not work with MySQL or Oracle. So majorly I work with SQL Server and MongoDB and other ones as well. Um, But I think that's something we can still attempt. I'll just try to Google it out and see what we have. Who is studying this? Let's see. Is it possible to have kind of PDF of the slides? Sure thing. Okay, hi, Sophia.
Hi, Samuel.
Hi, good to have you again.
Yes, this is the third time we are meeting this week. This week is the most productive week for me. Thank you so much.
Right,
Um,
welcome.
I have a question, and it's about this SQL application. Where you are currently learning this SQL is on data camp. So it's just like we can write the query and everything through the app. But I've
Mhm.
been trying to install SQL on my laptop. I have this SSMS, developer edition, and everything, but it's not working. Even if I want to launch the SSMS, it's showing that I should repair it. Even after clicking repair and restarting, it's still telling me the same thing. So I'm even confused. Which one should I download? Which one should I install on my laptop? Which one is good? I don't even know. I'm confused right now.
Um, so I think that's a problem with your device also. I'm not sure. So if you have any instance of SSMS on your device already, you want to have them completely removed, right? And then try again. You want to have them, ensure that you have them properly uninstalled. Once you uninstall it, restart your device, and then you should try again. Also delete the files that you may have on your end, right?
Okay. Another thing is, if the SSMS, can it work independently, or I have to download a server or anything for it to work? How does it work?
Yep. It works independently. So what you need to do is, when you download, what you get to download is the DBMS, and then you also download the SQL Server Engine, right? So they both work hand in hand, right? The DBMS is the one where you get to write all your queries, and then the SQL Server Engine, you also have it downloaded. It's the one that does all the processing and the likes, right? You'll not be able to see all of what happens there, right? But then that works as well. So you just have it downloaded. I'll give me a moment. I'm trying to set up my environment. So I'll just have a link shared, and then you can download both the SQL Server and its associated platforms.
Thank you so much. I will appreciate that.
If there are any questions, please go
Thank you
ahead.
so much.
Yeah, you're welcome.
Okay, so Utibe's hand is raised. So Utibe, I think you can go ahead.
All right, so I want to appreciate Mr. Samuel. Beautiful presentation. But the question goes to him and also to uh, the community. All right, the community management. So I wanted to know if we can have another session that we can actually delve deep and more like a practical, hands-on explanation. All right, because I really enjoyed this session because I think when I started up with my SQL training and learning, I usually I think I had a phobia for SQL and all that. But I think going through all these sessions actually exposed me, and I'm getting familiar, and then coupled with the learning on data camp. All right, I'm getting familiar with this language. All right, so I'm asking if we can have another session, and then we can actually either take up a data set and apply some of these things, practical data set, a real life data set, and solve a particular problem or something. That's my question. I think it will also help internalize what we've learned. Yeah, thank you.
All
Um,
right.
yeah, please go ahead. I wanted to address that, but please go ahead.
Oh, no problem. Okay. So I wanted to say yes. definitely we can have another session. Yeah, that attends to this need. So I don't know what someone wanted to say. I don't know if he wants to say, okay, we can take one now.
Um, yeah, so I think that works, right? It's going to require a lot of time, but maybe we can schedule for another session for that and be able to like roughly look into some things. I'm trying to connect to my Postgres environment, but I can only do that using my organizational logins. And okay, so let's try something else.
All right. Well,
So I'm gonna have my screen shared, and then let me just stop sharing this and share my screen. Um, so I won't be able to use my Postgres right now, so I would work with SQL Server. But when we schedule for another session, I will get like a different version of that, so I should be able to work with it. Let me see if I can do this. So we'll just quickly look at some things real quick, and oh good. Let me know when my device is on, and yeah. Okay, so I believe my screen is up.
yes, we can see your screen. The
All
screen.
right. So we're currently on SQL Server, right? SQL Server Management Studio, and here's like a what's it called? An ELD of a particular table, right? We basically talked about all the
Can't see the screen anymore.
Your
okay.
screen has gone off.
I can't see the screen
Can't
as
see the
well.
screen.
Okay, so let me see. Okay, let me know when it's up, and if it goes out again, I'll probably just have to share my entire screen.
It's up.
All right. Okay, so here we have an ELD of a particular table, which should be for the Superstore data, right? So we have an ELD, and then we can see an ELD is entity relationship diagram that basically shows you how one table is connected to another table. When I click on this or hover my mouse on it, it tells me that the foreign key other products orders is connecting the orders and the other product together. So there's a foreign key constraint that lets one table connect to this other table, right? And then we can see the keys. The foreign keys are the ones doing all the connection. And we can see that there's no connection between the product and the customer, but there are connections between the other products and the others, and of course the customers and the others. Now, because we have some of these connections, we can be able to still use this and get the product of what the customers have ordered, right? So because of the primary key foreign key relationship, we're able to achieve some of these operations. Let's have a look. Let's do something real quick. Now, when we talk about database creation, right? Like I mentioned, we can be able to work with Postgres right now. It's off again. Okay, so let me share my entire screen. So let me know when it's up.
It's up.
All right. Okay. So we have this create database, right? Let's just do this, and I believe we are aware of comments, right? Are we aware of comments?
Yes, we are.
All right, awesome. So we're just going to call this creating a database. So we'll call this create database, we'll call this TAMP, right? And then we can have this. Now, the semicolon that we have here, in most cases, it is usually optional, right? It just specifies or indicates to SQL that, oh, we have come to the end of this query. right? Now, once we have the SQL understands, but regardless, we can still execute our query without having that, right? So once we decide to, let me increase this, and I'll just make it 150. Okay, so when we still go on ahead and execute this, it tells us commands completed successfully. Now, remember when I talked about naming conventions, right, which are very, very important. We need to understand how to name our variables. We have variables and we also have the values, right? So variables and values. What are your variables? Think about them like your containers that hold your values. And think about these like your values that go into your container, right? So you have this. Now, how do we mean? For example, you're filling a form, there's the name, there's the age, there's the location, right? Now, for each of these, we have a variable name. Each of these are variables. They are containers that will store what information? Name information, right? So these are all the values, right? And then we have my age is always 12, can't be more than that. And Esther, I think Esther should be like the eldest. So we have Lagos, and let's put Abuja, and let's put Ibadan, right? In some people's accents right now. So let's just use Ibadan. Okay, so I believe this is good. So basically, when we talk about naming conventions, right, your variable names has certain rules that they need to follow. For example, we cannot have spaces between your variable names. We cannot have spaces between your variable names, right? That's not something that will get allowed, whether in Python, in JavaScript, HTML, any programming language that you can think of. But in SQL, we can have that happen. Now, it takes an exception, right? For example, we want to say create a database called TAMP data mentoring session. Now it's showing me an error that there are spaces in between this name. So we cannot have this done, right? This cannot be done. Before that, let's confirm that we created the other database successfully. So I'll just refresh and we can see it here, right? Now remember what I mentioned. You only write the create database and specify the name. But when you click on the plus button, you can see that it comes with a lot of components. There's your database diagrams, which you can create. There's your tables. We currently don't have any table because we have to create that. There's your views. We currently don't have any because we have to create them. Also other things as well, right? Now in security, you can be able to find out who are the persons that can access this particular database. Currently, I am the only one because this is my environment. It's just me, right? DBO, guest, information, and the system admin. So I'm currently working with the DBO, right? So it's just me. In an organization, you have like lots of persons in the users or in the roles, depends on whichever it is, right? So this is basically for maybe your organization uses SQL Server. Maybe in the next session that would schedule, we'll look at it in a Postgres perspective. Now we've been able to create this database, but it does not contain any table. So let's look at how we can create a database by allowing spaces inside of it. Now what we're going to do in order to do that is to enclose it in square brackets. When we put it in square brackets, SQL understands the square bracket says this is a variable name. Anything in between should be allowed to pass as one. Now, this is the only way that we can create a variable. By variables, I mean your database name, table name, column name, procedure name, index name, view name, and whatever you can think of, right? So those are your variable names that we are talking about. Now, if we do not enclose it in the square bracket, we cannot be able to put in spaces. So your naming convention rule states that spaces are not allowed. Instead of having spaces, you should instead replace them with underscore. So this way, if I remove the square brackets, this is what we have. Still good to go. And then we can have this highlighted, executed, and we can decide to still keep it how we had it before. So this way we'll be creating, still the same. Okay, so we have it in space. So it tells us that, oh, this database has already been created. So let's do this. So we now have two databases created, one with space and the other without a space. I'm just going to increase this to this. So one with a space and the other without a space, right? And of course, we can also decide to have them all tied up together, right? By just keeping them here. So this works, right? But in the case where you need to do something like this, in order to aid readability, you want to ensure that you're keeping all of these guys proper. For example, we're going to do data, just keep this mentoring, and then we'll call this session, right? So we're having it as TAMP data mentoring session. So the TAMP can stay in capital letters. And we'll have this created. Now, one thing about this is that all of these that we've created are different from each other. So when it comes to programming, you cannot say, oh, I want to use this one, whereas you're trying to call this one. They are all different entities on their own. Now, for each of them, we need to create tables. So let's go on ahead and create our tables. Creating tables into our database. Before that, we need to first activate our database. So activating our database for use. So say use database, call it TAMP, and we can see suggestions of all the TAMP databases that we have. So let's do this. I can't see the one I want. So I'm just going to clear it off. And I can decide to drag it from here into here. And this is it, right? So I can put this if I want to have this highlighted and executed. Now it tells me commands completed successfully, and I have activated this database for use. All right, so you can only create your database in your master database, right, which is going to be default when you sign into SQL Server, right? Now we activate this so that we don't end up creating our tables into the master database. Now, if you check here, you'd notice that I have the master database and there are some tables in the master database like this. So when you do this, at the end of the day, you start looking for your tables. Oh, but I created my tables now. Where is now my tables? This is because you did not activate your database before creating the table. Now let's proceed. So we want to have these go into TAMP data mentoring session table, DB rather. So let's create our table, create table, and we're going to call the table, let's see, let's call it data analytics mentoring. So pardon me if my texts are wrong. I don't know how to spell. So we'll call this this, right? But now you notice that we cannot create a table this way, just like we have created a database. In order for us to create a table, right, we need to define the components of the table. Now, when I talked about schema, let's do a quick example of schema. I'm just going to work with the Adventure database. I'm just going to do it. Use Adventure Works and select. Let's just execute this first. So we can do select all from the adventure works dot person dot person table. Now, you may be wondering, why are we bringing the database name here, right? This is because we're trying to say, in order for us to get to this table, we need to find the database first and then find the schema inside of the table, inside of the database, before we can then locate this table. So remember the example I gave you, you need to leave your work and get to your home. This is your work, and then you need to get home. You need to get from here, get a bus, get into your street, and then get to your apartment, right? Before you are then able to do whatever you need to do in your house, right? So this is basically the schema that we talked about. So let's quickly create this table and then define all the both constraints as well as the data types that we can give it. So create table, we're gonna call these, we can open up a bracket here and say, first off, we want to have an ID column. And let's say participant ID. So let's call this participant ID. Or what is this? So participant ID, let's call it participant ID. And we're going to give it a data type because it is very important. So I'm going to call it data type integer. Now in SQL Server, right, it's a bit different from Postgres, but in SQL Server, what we do is we want this ID to be a foreign key, a primary key rather. So I'm going to say this is a primary key, right? So this is going to be my primary key column. Now, in making it a primary key, I
Screen is
also,
out.
my screen is what?
Out.
Okay,
No, I don't
I don't,
think the screen is out. I can
It's
see
not
screen.
out.
It's not out. We can see it.
it still looks like I'm sharing here. So I
Yes,
It's
think we
not
want to,
Yeah,
out.
we
You
can
can
see.
see it.
all right. Now in SQL Server, right, I want to be able to say this column should increase by default, which means anytime a data is entered, it should take 1. If another data is entered, it should be 2, 3, 4, and keeps on progressing like that. So I don't manually have to input all the data here myself. Now in Postgres, you make use of the serial, right? I'm sure we are aware of the serial. In Postgres, you make use of the serial. In MySQL, you make use of the auto increment, but in SQL Server, we make use of the identity one by one or one-on-one. So let's look at what we're going to do. So I'm going to bring this here and say participants ID data type integer, and then I'm going to call it identity one and call it the primary key. So now I'm saying I want it to increase by 1 for every time a new record is being entered. Increase the primary key by 1 every time a new record is being entered. And then we can have other columns, maybe first name. So let's look at the person that also gave that example. So first name, we can have it as Vakal 20, can do 20, right? And of course, we need to put in a comma here. So Vakal 20, we can give it a not null. And we can also say we want it to be unique, right? So this is us saying this must collect data. It must collect data, and the data must be unique from every other one. Let's clear this off. So we'll put it in the other one for the full name, so we don't eventually miss out on some people's name. So we can also call this variable character 20 and also ensure that it takes in data. Not null, and let's do full names. And just call it full names, right? Or like let's do full name. Variable character, let's do 50 for the full name. And not null, we'll do unique. And not null. right? So you can see that we're setting our constraints also in this case, right? So let's also see what next we can bring in. Location. Let's just put in email address. So do variable character also, and let's do around like 20 for that, and let's say not null. Right. So we need to ensure that each one of the rows are separated by comma in order for us to properly get that right. So we have the location. The location is saying, oh, this is a recognized function in SQL. So what do you want to do? Now, if we have these, we can have location and state. They are recognized function, but this is absolutely fine, right? In a case where we are kind of bothered by why the other ones are black and then this is giving blue, which means it's a recognized function, what we can do is to enclose it in the square brackets and it stays this way. So SQL understands this is a variable name and I will not treat it like a recognized function. Now, whether we do this or not, it will still go through, right? Because it's a part of our create table statement. So we can have this done and let's see, and give it a variable character, and let's also do, let's just give it a character. Let's see. So okay, so we can't use geo. Let's give it. Let's just give it a character of 20 also, and ensure that it's not null. So let's also make it unique. I think we're fine. And then we can also set a check and default. Let's set age. Age would be integer, right? Not null, and check that it is greater than 18. Right. So we have comma here. So check that the age is greater than 13. Check age greater than 13. See, incorrect syntax, expecting, no. So let's see. Should be good. Okay, so not sure why this isn't working. So I'll come back to this and see exactly what the problem is. So let's also do a default. For default, we can say, let's see what we can use for default. Let's see. So we can use a default location. Yeah. So we can use a default location instead. I'm trying to see which one works best. Use age for default or okay. Let's use occupation for everyone on the call. Can everyone see my screen?
Yes, we can.
Yes, yes.
All right. Occupation and okay. So we can set occupation to character, and let's set for 20. Do this. Occupation to character, set it to 20, and we're gonna put in a default value of let's do so we're going to put in a default value of data analyst. Not sure why this is giving me age should be correct. Just not sure why it's doing that. Integer, no, check. Okay, let me try this again. Age integer. Check that the age is greater than 18. Okay, so that's fine now. Yep. We can also have it as not null. Not null here. or we can put the not null somewhere on here. Right. So once we have all of these, what it basically allows us to do, of course, we need to close our bracket and do this. Right. Let's see. We need to create another table. In order for us to have a foreign key, we need to create another table. And then the foreign key would reference the other table. But I think so far, we've done for the primary key, the not null, unique, the check, and the default. Right. Now, the last one that's remaining is for us to do for the foreign key, but we would need to create another table to have that effected. Once we do this, commands completed successfully. So we can refresh our databases, or we can refresh only that particular one. And let's see. So we have our table created here, data analytics mentoring session, and plus button, and we can see all the columns that have been created with their data types. When we go to constraints, you should be able to see the constraints that have been created, check constraint and default constraint. Right, let's see, we had the unique constraint. Not sure why that did not take effect. But we have in keys. Okay, so we have the unique constraint in the keys, and we can see the primary key that we also have here as well. Right, so when we have this queried, select all from, I'm just going to drag this from here, select all from this, and we can see these are all what we have. Right, let's quickly see. Now, one way for us to be able to get data into our table will be, if you do not want to use the insert, you can actually do select and then specify all the values of the columns and have them inserted into your table, right, using the union. But we'll look at that later on. I want to see how, if I have any table that contains similar things as these. And let's see, give me a moment. Just gonna close these and close this. Just gonna do this and let's see. Select top one, all. Okay, so I wanted this to give the table names, but it won't. Let's see. Just got columns. Let's see what we get at the end of the day. Invalid object name six dot columns. Select all from six dot columns. So this won't give us the accurate stuff that we have that we wanted. Any computer for database. So let's just proceed. And let me see. So I want to see how we can quickly insert the data without having to like specify each of them one after the other. But we probably have to insert into our table called this guy. Insert into this table, and we need to specify all the values that we want to insert, right? Excluding the participant's ID. So every other thing, first name, last name, the full name has a default, a unique constraint, so it must be different from every other table or record rather. The location has a default, so this means, okay, location is cool. So the occupation has a default. So this means if nothing is being entered for occupation, we would end up having a data analyst role for everybody. Let's look at that. First name, start into this. So I'm going to open the bracket and this. First name. Okay, so my column names are not coming out, and that's because we have all of these errors here. Okay, so everything looks good. Let me clear this guy here. So first name, comma, last name, comma, full name, comma, email address, comma, location, and age. Right. So we'd have the values, and then we can now start putting all these information. Right. I believe we all know that we need to have them enclosed in quotes for text data. Okay. So I'm just going to do my email address as Iheagwam at TAMP session.com, and location would be Lagos. Age would be let's put my age for
12.
yeah. I'm always 12. I've never gone past that age. So let's put let's say Esther. So Esther is like my favorite dummy character. Esther Badmos or Esther James. Let's do Esther James. So we have Esther James, comma, and so let's do established James at TAMP also session.com, comma, let's do Abuja, and let's give extra 34. So we're going to put one more data and see what we have. So let's see. Badmos. Let's put Emeka. Yep, let's do this. Let's do Abdul. So we have Badmos Abdul. And Bad Abdul at TAMP session.com. So let's do Kano, and we have age of, let's see. Okay, so let's do 23. Now these are the data that we want to have inserted, right? And then at the end of the day, we need to put this. Now, if there's anything wrong, if at any point in time, maybe any of our variable character gets exceeded, it's going to throw us an error that we cannot insert that data. If if it sees a repeated names or a repetition of names, it's going to tell us, oh, we cannot insert that, as it is going, it's giving a violation of the constraint that has been set. If the age checks and it sees that the age is not up to 18, just like I have, it's going to reverse the whole process as well. So let's have a look at this and see. Inside this string of binary would truncated in this for what column? The email address. Why? Because based on the text character that I have selected, this seems a bit much. Is it supposed, what's my email address? 20? Is this even up to 20? Let's see. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Okay. So yeah. So this means that it's getting truncated by about 3 or 4 values, because it is going more than the limit, the size of the column that has been set. So in order for us to do this, we need to either drop our table and recreate it, or to alter our table and ensure that we have it proper. So let's do this. Alter table. This is our table. And then we'll alter column. What's the column name? Email address. Just do this. All that. Okay, so I'll give this like 25. And okay, so this worked. So I can try to insert it. So this time around, it's no longer going to tell me that, oh, it's this. Now it's telling me there's a check constraint. When it checks, it can see that the age is not up to 18, right? So the data cannot be inserted. So this means that the check constraint is doing a great job. So unless I have to come here in my data and say, you know what, let me grow a little. Let me put it on 19 and I try to insert again. So what happens? String of binary will be truncated for who? Established James also. Okay, what's this? Okay. So we need to increase that a bit. Let's just keep this at
It's more
around,
than 20.
yeah. So let's just keep this at around 35 and we should be good. So let's see what we have. So 3 rows affected. So because we needed to check our constraints, this is what we now have. Now notice we did not input any data in the ID as well as the occupation. They are going to be automatically filled. Now what happens in the ID? Because of the check constraints and all the other enforcement that we have, it keeps on counting. Oh, data was tried to, we tried to input data once, it refused, we try to input it again, it refused, we try to input it again, it refused. So I'm going to start counting from the next one. Right, now we can see that we've been able to sort all of these, but in a typical organization case, how do you eventually get this particular stuff sorted? Right, measures used to be put in place or needs to be put in place to have it sorted. But another thing we can do is maybe in SQL Server, right, we can use what is called the identity insert to have that done, right? In this case, in order for us to do it, we need to clear off the table and then have this information imputed again. Like I said, in a typical organization case, you may not necessarily need to clear off the table, right? It would be embedded into the maybe the application or the form, and all of those will work, right? So if it looks at this and it's already taken, it goes on to the next one. But if it's not taking, it has to pick up that number that is not taken. But in this case that we need to do this, then we need to make use of the identity insert for it. Right. Would not be able to, I think we should be able to do some update. Let's see if we can quickly do some updates and updates table. So updates table and set the participant ID into case. We're just going to do a case. Case when participant ID equal to 1, then equal to 5, rather. Equal to 5, then 1. Let's just bring this here. When the participant ID equal to 6, then 2, else 3, right, and we can end it. Right, so this would basically help us. We can decide to put this in brackets if we want. Yep. So if we want, we can decide to put something like this, and let's see if this works for us. So cannot update the identity column. So this is absolutely great, right? Now, in a case where you're trying to update this and then it tells you, oh, this is an identity column, it's a primary key and it cannot be updated. So there are other things that we can be able to do to have it sorted. Let's see if we identity insert this on. set this, let's set it off again. So let's see. So we can't do that because we're not trying to insert data. Incorrect syntax in the identity insert. So we most likely have to clear this off and then input it again into the table, right? And then that way we should be good. I'll just do the identity insert from here, copy and put this. And I will just put it somewhere around here. So there are quite a lot of things that you'd get to learn about as you identity insert this on insert into this. Okay, so we'll need the 1, 2, 3, and we need to include the what's it called? Participant ID, comma, first name here, comma, and we should be good. So I'm just going to have this. Let me clear this off. Truncate table this. So I believe some of these things I'm doing, except for the identity, right? We're all familiar with them, like the updates with case, truncate table. Invalid keyword, identity insert. Okay, sorry, set identity insert rather. Set identity insert. So that should probably work. Set identity insert here. Let's see. Set identity insert. So that should probably have worked. But yep, let's just give it this and try. So 3 rows affected, and we can check it out again. Right. So this we can now see, and then any new data that gets entered, we don't need to include the ID again. So it will just keep on getting entered as the data progresses. Right. So there's a lot that we can look into, but maybe when we look into the next session, right, then we should be able to look at that. Do we have any questions? Let's see. Since we're updating a column, there's no need. If you're creating a column, it's recommended. Network Abscon was okay. Very rich session. Thank you very much, Muhammad. Right. So by next week, I'm sorry, not next week. Maybe on the next session. I think I'll be occupied for next week.
I have a question, sir.
Yeah, hi, please go ahead. In the next session, maybe we would probably look at working with Postgres and then looking at many other things. So we should probably look at, I'm sure in the course of your journey before the next session, we should be looking at things like maybe your joins, right? Please go on ahead with your question.
Okay, so my question goes thus. Instead of inserting all those data, is there a way we can, like, if I want to get data for an organization, like those that are in this call, I want to get their details, is there a way I can share the link just as Excel sheets? Now I can send that one to get all those things. Is there a way I can get it? Because if I have like 100 names, I can't enter it manually.
Oh yeah, absolutely. Give me a moment. Function. So maybe the next time we meet, we should be able to talk about stuff like this. And yep. Now, let's say you needed to, you have an Excel file, like you mentioned, right? You want to bring it here. What you do would be to click on your database and import it as a data, right? So you import your data. Your flat file would be for your CSV, and then you have your data for Excel. You select, this is your data source, a Microsoft Excel file, and you select the file path. Figure out where exactly you have the file stored. Let's say I have this pay gap for let's see. Let me see one that works. Not sure if okay. So let's do list of countries by literacy rates, and let's do this. I'm just gonna put the 2016, and first row has column head names. It's not registered for local machine. Blah 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 blah. Okay, so let's try for CSV. Let's look at a CSV file and see if that works for us. Let's see. I don't actually have any file here. Okay, so I have these. I'll just pick one of these guys. Let me do for the results. Open, and we have this. Now this is what the file looks like, right? It's an Excel file in CSV format, but this is what it looks like. So we can bring it to our database and select destination. I'm going to select OLDB driver. No, I'll select SQL Server. So this is fine for me. This is my database where I want it stored. Otherwise, I can change the database to any other database I have here. So I want it stored in this particular one. I'm going to click on next, or we can create a new database for it if we want to. Click on next. It tells me this is what it is on my device, and this is what is going to be on the database. So I can decide to rename it here if I want to, Olympic results, or if not. Once I'm good, everything is fine, I can click on next, and it's going to check if the data types on the Excel file meet with the standard for SQL. If it does, it's going to import the data. So let's see the error here. Data conversion failed. Data conversion for column results description returned status value for, and this text was truncated. So it showed some error, and then let's check it out. Let's go back. Just do this and can try it out again. So it's a data type issue. Let's see. Okay, let's see, column delimiter. Okay, so we should be able to see, let me see for advanced, we should be able to get that. Column delimiter result description is currently on, okay, string DTL string, and let's see, suggest types. And let's change the type from 200 to like 20,000. Number of rows, no, so this isn't correct. So we're supposed to be able to have that to easily change the data type. I'm not sure why it's not showing that right now. But we can look at it differently. Let's see. Column names in this. Okay, so let's proceed. Next. Next. Okay, so somewhere around here, we should be able to see that. Not sure why it's not giving that particular thing. Let's see. Result description. Enable identity inserts. Let's see. Nullable size. We should be able to change these values here. So we can't do that right now. So I'm not sure why we're unable to do that, right? But it's something that we should be able to do before we even proceed to this point in time. Let me have a look at it again. Not column delimiter also. This is the column. We can't do anything right now. Not sure why. Okay. Data type. Let's see. Change it from here. Okay. So this should work for us. So just going to change it to text. So we can see that there are lots of data types here. Let me use text string, dt text, and let's click on finish. Okay, so lots of error. There's already an object named this in the database. Possible. Okay, so a moment. Just refresh, and let's see. Okay, so it's eventually created, but then it's going to get truncated. Let's quickly check that out. So it's going to get truncated because of the data type that we saw there. So no data in it, absolutely, right? So let's drop this. So we'll just try to quickly get that. Drop table. So a lot of times when you're trying to bring in your stuff, it's pretty much easier than we currently have it right now. So let's go back and try again. So we still have an error on where. So another column, I think so. The processing file has started this multiple step, blah blah blah. The column result description binding was DT text. The column type is DB in status, unsupported conversion type. So basically just have to fix it. This changing from this to the destination type of this might not be supported by this provider. So you can see that it's giving us all the errors, and then we just need to have it properly fixed. Once we have it fixed, we should be good at the end of the day. Let me see if we have another data type that might work. Please let me know if you have any question, and then we can wrap up.
Okay. Thank you so much, sir. Another thing is, for example, now in Excel, if I just send out an Excel sheet, and once they fill it, it will keep on updating. So if I should send in this file to SQL, and maybe someone now fill in the Excel sheet that I sent out, will the updates show on SQL, or I will have to transfer import the file again?
So that's a very tricky question. So by default, it will not show up by default, right? Except you have a way for your database to connect to your Excel, and then it has to take the data, right? Other than that, it will not connect. But I believe we have like a function to connect Excel and your database together, mostly SQL Server. Right, there's a function for that, and it should be able to work.
Okay, I'm so sorry, sir. Another thing, can SQL work on its own? Like just sending, maybe there is a link for SQL to collect data. Is it possible?
I'm not sure I get your question.
Like Excel now, I can send out the link for Excel sheet to get data. So SQL too, is there something like after creating the table, maybe the link, I need some data for it. Rather than importing the data, I want to collect it directly from the respondent. Is there a way I can do that through SQL?
To collect it directly from the respondents?
From the respondent, yes.
I don't think so. I think at the end of the day, right, SQL is just like a back end side where all your information gets to go into, right? So it's a back end side, not really something that you can give out to people and then they can fill in whatever they need to fill in also.
Okay, sir. Thank you, sir. You've answered my question.
All right, so give me a moment. So
I'm
hopefully,
still expecting the link code.
Please remind me the link.
Okay.
Okay, I don't know. I don't think that was for you. But
Yeah.
then someone asked that how can he get a similar app to what you just used for the MySQL. So
Let's see. Let's see. So we can do SQL Server download. So we can do SQL Server download. We can get it from here or so. So let's click on this, and you should be able to get it. So if you work in an organization, either of these should work for you. Otherwise, you can either get a developer version or an express version, which are absolutely free, right? Then you can just even select Windows. So when you click on this, in most cases, you want an express edition or a developer edition, whichever works for you, right? You can just click on download for either of them and then get it done. Or you can get it in your Windows or as a virtual machine. So let's do this. We're going to select Express, download now, and it takes us to So it's downloaded already on my device, not a large file, but when you're installing it, it would require you to also proceed to getting another file, right? So it will require you to also get in another file, get your basic installation, and then you can do other things, right? Once you do this, it tells you, oh, you need to have other things done. Once you do all those other things, then you need to download the SSMS. So SSMS, this particular one is the engine, right? That you get to, all your queries get to process. Then you need to download the SSMS, which is going to be where you can perform all your query writing and the likes. So there's also SSMS. I already have this installed on my device. Exit, yes. So there's
Is that
SSMS here, download SQL Server Management Studio. And then you can just download this, download SQL Server. If you don't, then this is SSMS. So you can download the latest one, which is 20. I think I currently use 19 or 18 on my device, but then you have this as well. So it's like saying you're downloading Postgres, right? You download the Postgres itself, and then you're downloading pgadmin, where you can perform all your stuff. So the Postgres is like the engine where everything works, and then the pgadmin is the interface where you get to interact with, right? Just like this. And then I currently only have my organizational stuff here, so I may not be able to um, connect to
progress
any
and
of the
picture
servers.
admin?
Yeah.
Progress and picture admin.
Yeah. So
Okay,
PG. So once you have that, you should be good. Right.
ex- said the Express and the SSMS. I've downloaded the Express version, even the developer version. I have it on my laptop already, and the SSMS. But I think it's because I downloaded the two. That's why it's not working.
Hold on. So give me a moment. Let me share you a link or something that would help for that. Um, okay, just give me a moment. If I'm not sharing, okay. Just give me a moment. I would get you a recording that actually works.
Okay, sir.
So I need to run off in a few minutes. I believe we're all good so far from the session today.
Yes, yes, yes,
Yes.
Samuel. It has been an awesome.
Right, awesome.
Me, I
Um,
really, really enjoyed it actually. So a big thank you to you. A big thank you to everyone that joined. Thank you all so very much. I'm so sorry to cut you, Samuel. It's like you wanted to say something.
no, that's absolutely fine. I'm trying to get a link and then share.
Oh, okay. Right. So I'm going to say thank you. I don't know. I feel like I wish I could just give our mentor today $1 million. Or probably, I don't know. Because I know this thank you can cut it because you've really helped our mentees today. Actually, they really learned a lot and you've really helped put clarity to a lot of things that has been fogging. So thank you very much. We hope to have another session with you. I mean, this session was awesome. So we can't wait for the next session where you would teach us or teach us the practical hands-on on PostgreSQL. So thank you all also for joining. God bless you. Thank you, Samuel. So I think that's it for today. So we can all be yes, I already shared the um attend the link to the attendance way back. So I don't know, some people that have not seen it. You can just go through the chat. And let's just say a big thank you to our mentor. I mean, a big thank you to our mentor. Thank you very much, sir. I'm very, very grateful. So yeah, we've come to the end of today's session. So bye everyone.
Please hold on. Let me quickly share this to the chat before.
All right, no problem.
Then there's this also. Okay, so I shared a link to download and then a YouTube link that would help you go through the download process. Right. Should be good. Oh yeah. Let me put out my LinkedIn. Let's see. Okay, sure. So I have it in the chat now. Kindly connect with me and I'll be sure to connect back. Thank you very much, everyone. I'm super honored to do this, and I look forward to seeing you the next time.
Thank you so much.
Thank you very much, Sophia. I'll see you again also.
Yes, sir, we will.
Thank you, Samuel. We are grateful.
All right. Thank you very much, Samuel.
community.
Thank you, everybody.
Hello, please, how can I get my ID from
We sent an email,
engineering
like
track?
we sent an email. Kindly check your email. You'll find it there.
Okay, thank you.
Hello, please, where is the link for the attendance list? The link for the attendance list.
Is there. You will see it.
Is it the message?
Yes, check through the chat.
Okay, thanks.
Have you seen it?
Yeah, it's not going through. I've clicked on the link, it's not going
It
through.
was now. It should, because I just did mine now.
Please, what are we going to use as the ID?
Check your mail. It
You
has been
were
sent to your
sent
mail, your
a
ID.
mail. Your ID number is sent to your mail. So you just follow the.
Hello, sorry, I can't find any mail. I just checked my mail. I don't see any mail.
Me, I
Very
never see
sent
anything for my
a
mail.
mail.
I
Huh?
wasn't
The
sent a
mail
mail.
has
I've
been
not seen
sent to
anything
you
in my
Check
mail.
your junk mail.
Sorry, please, which day
Check
was it sent?
your
yesterday.
junk or your spam.
Yesterday.
Where is the register link? I can't see the attendance register link.
I can't actually find it here. I'm in the spam folder and I can't see it. Can you tell us the name of the person or the address so we could search for it? Hello?
Search with what's it called? Hold on. Tech Up Africa.
Oh, August 5th. Boy.
Yes, on Thursday. Between Thursday, Wednesday, and
That's on
yesterday.
15. Okay. No, the one I have here
Yes,
is your
yes.
assignment is due soon.
No, data analysis ID. That's the subject. Then
Oh, please.
Data science
one
ID.
Jacob planner. I hope this makes sense.
Yeah, yes, I've seen it. Yes, I've
Oh,
seen it.
please excuse me. The attendance is it not
Okay.
also meant for those in AI engineering? Hello.
What?
I said the attendance is not also
What did
meant
you
for those.
say?
I said the attendance is it not also meant for those in AI engineering?
I think for every class you are doing, it has a different code. For data analysis is DA, then the name you have there. Then I think, I don't know, just check.
Yeah, I can't find anything.
Wait, I don't now know how to help you. This one that you can't find anything because I'm about logging out.
Sorry, please. I've been on YouTube, but I couldn't. I just wanted to take attendance. I joined in on YouTube for a while now, so I just wanted to take my attendance before I go.
Okay, maybe I should just copy the attendance link and share it to the WhatsApp group. I think
Okay, that
that's
will be
fair
fine.
enough. All
Yeah,
right.
thank you.
Please, if you can resend the ID to be fine because I did not receive it. I just checked my everything in my email. I don't see anything.
The IDs came on 15 August. On 15 August, there's an email with a link of your names. Then you check where is your name. Then you check the number on your name. When you are doing data science, you say DS01 if you are on number 1. If you are on number 30, you say DS030. If you are on number 100, you say DS100. So you check on the list which was sent on email on the 15th of August. Here in Central Africa, it's around 5 p. It was 5 p.m. or 6 p.m. You check your email. Check your spam folder. Check your spam folder if you maybe the message got to a spam folder.
Honestly, I checked everything. I can't find anything.
Hello, good afternoon. Hello, good afternoon.
Hi.
Mr. Trinity. Mr. Trinity.
Yes.
Hello.
Yes.
Okay, please. I don't know if you're on the data science group. Are you on the who is on the data science track here, please? I've been trying to open the link on my email and it's not opening. Like the spreadsheet is not opening. I don't know if you can just help me check my name, so I'll just know my ID.
All right.
What's your name?
I can
You
check
have to
your.
download. You have to download Google Sheets.
Teacher
You must
Umpo.
have a Google Sheets application.
You want me to check your name for you? I can do that.
Okay.
So what's your name, please?
Please do. I think that'll just be the easiest way.
But you
What's
have
your
to
name?
download
Isha Umpo.
You said is what?
Google Sheets.
Isha Umpo.
ISA. ISANTO, right?
ISHA.
Okay.
Then space MPHO.
NTH.
Yes, I needed
ISHA.
to.
MPHO.
Okay. MTHO. MTHO, right? Uh, I
Hello,
cannot.
please, can you hear me?
I can only
Fine.
see one.
Mama. Come here.
ANISA. Isa.
Umpo, right?
No, Isa Bello also.
MPH.
Let me search again. Hold on, please.
No, that's not me. Is that the data
ISHA.
analytics part? And come
No,
out.
data science.
Oh yeah, is it?
It's data science.
Yes.
This is data science track.
No, no,
Are
no,
you
no,
are you
no,
in
data
data?
analytics.
Okay, no, I'm in data science.
No, no,
Data
no.
analysis. Okay, what's your? Let me help you. Name.
Data analytics track.
What's your name? What's your email?
Isha
Sorry.
info, please.
That's I, right?
124.
Isha. Yes, ISHAMPHO.
For at Gmail.
Yes,
Are you
yes,
with me?
yes.
It's 167. Your ID is
That's a
ending
166.
167.
166. Okay.
166.
So that'll be DA
Isha.
166, right?
Yeah, it will be DA
Yes.
166.
Yes.
Okay. Please, what of the link that we are
Yes.
to the
I've sent you to the WhatsApp group. Yes, I've sent you
okay,
to
I
the
sent it.
WhatsApp group. All right. All right.
Or even
Hello, please.
Guys,
Thank you so
bye.
so much.
bye.
You're welcome.
Hello,
See you guys.
hello, please. Can someone send link for
Bye.
Oh, bye. Yeah.
data
Ababa
engineering?
ababa
See you next
ababa
time.
ni rangu lere.
What's the issue?
Then
I said, please, can someone help me with the
natawa.
Google sheet for data engineering so I can check my ID?
Okay, no. I think they sent it per course you are doing with them. So I'm doing data analysis. That's why I'm able to help Isha. So maybe you should ask on the WhatsApp group.
All right, thank you.
All right. Bye.
Allah Akbar. Allah Akbar. Allah Akbar. Assalamualaikum warahmatullah. Assalamualaikum warahmatullah.
The group is link open.